So you can imagine, in this scenario we just talked about, if you wanted a robot to crawl across rough, bumpy terrain, the snake might not do so well, but the hexapod might do pretty well. Now, on the other hand, if you needed a robot to crawl up someone's leg, the snake is what you want. The hexapod, maybe not so much. But, you know, really, if you wanted to climb up a pole or something like that and climb on top of a building, you might design a robot to look like a snake and not a hexapod. So these are, you know, they might have the same amount of motors, they might have the same number of sensors, but just arranged in a different configuration. It's a different mechanical design. And it really dictates where you can use your robot and how effective it's going to be. So there's a real art to designing robots like this. Don't be frightened. It's just, it's harmless. Okay, so last part of every robot is software. Software really coordinates all the parts that we've talked about. They process the sensor data and extract something useful from it, for example, telling you where the road surface is. They coordinate the motion of the actuators to allow the robot to move in a certain way. And they also make higher level decisions. You might want your robot to decide how to get out of this room. And your software would determine how best to move through this auditorium to get from here to the exit. And that's exactly, you know, what the robot in this video clip is doing. It wants to get from where it is now to that red patch on the ground. And it wants to avoid these black regions, which are obstacles. And you can see, I mean, you can almost see the robot kind of thinking about it, running its software. We call this a planning algorithm. It's trying to determine how to get where it wants to go. And it's maybe not doing the most efficient job, but it's slowly meandering toward this red spot on the floor. And this is just a product of some software that some computer engineers sat down and wrote. It's running an algorithm that's doing the same thing many, many times, and it's able to determine how to get from point A to point B. You can use software to determine how best to pick up an object, how to manipulate it. All these things that you've seen robots do are powered by different types of software. Okay, so those are some examples of robots. That's a kind of a broad definition of what a robot is. So what is a roboticist? I mean, you guys are here to learn about cool jobs, right? So a roboticist is a very cool job. And a roboticist is someone who knows about all these things: sensors, actuators, mechanical structures, software. And in my opinion, one of the cool things about robotics is that it draws people from many, many different backgrounds, right? So there's all these different aspects of robotics, and each one of these aspects demands a certain kind of expertise, right? So you may be a roboticist who focuses on sensors and sensor data processing. Well, sensors are usually electromechanical systems. So you may have a background in electrical engineering or physics to understand the underlying phenomena governing the sensor. Actuators are usually either electromechanical or mechanical devices. So the background that's kind of important for studying actuators is either mechanical engineering, electrical engineering. The mechanical structures, the really cool designs that you've seen, those are all designed usually by mechanical engineers who think about how best to organize these joints, what the size of the joints should be, how they move relative to one another. And then finally the software. Electrical engineers and computer scientists are usually the guys who are really interested in writing software. So they can sit in a room all day and write software and pair up with a mechanical engineer who's designed a cool structure, and all of a sudden you've got a robot. So what do roboticists do on a daily basis? Well, we design and build robots, and every time you build a robot, it means you eventually have to repair the robot, which is fine because when a robot breaks, you actually learn how to make it better. So here's a picture of some kids repairing a robot. We write software to control robots. We spend some of our time trying to write software to get a robot to move through a room, for example, to pick up objects. This is an art in itself. And we perform experiments with robots. That's actually pictures of me and a couple of my students out at the beach performing experiments with a robot that was sort of like a Mars rover, okay? My student here is in a coat and a headband. It was November when we were at the beach, so it's not as fun as it sounds. But some of the experiments are a lot of fun. So you do experiments and you learn about how well your robot's performed, and that's another way you can improve your system. So how did I become a roboticist? I'm not that old, but you know, when I was a kid, there were no classes in robotics. There were no presentations on robotics. Robotics is a pretty young field. But I always liked mechanical things, and when I was in grade school, maybe in 6th grade, I got involved with a group that was actually building a robot from a kit. It's this robot you see here in the corner. This is a Hero Heathkit robot, and boy, this is one of the oldest robots that you could buy and put together, right? It was a great experience just soldering the circuit boards, assembling the robot, programming it a little in a simple fashion, and eventually, you know, the thing rolled around the room, and it was a really interesting experience for me. It made me decide that this is something I wanted to do in my studies and then later in my career. I was interested in computers. This picture is here in the center is of the first computer I ever worked with. It was a Commodore PET computer. It probably has about 1% of the processing power of the computer chip in your cell phones. But we could still play games on it. I think it was black and white screen, maybe 8 inches, but it was a great experience to learn the basics of programming, and that doesn't change. The computers get more sophisticated, but the programming kind of remains the same. And so when I went on to study mechanical engineering at Michigan. I studied some robotics there, and so eventually you kind of fall into this field. But you guys are lucky today, because if you want to become a roboticist, there are a lot of things that you can do that I couldn't have done. First of all, you can go out and build robots yourself. So if you build a robot, by definition, you're a roboticist, right? So you can go buy Legos, kits from Lego that allow you to build a robot, and you can make a mechanical structure. It has sensors, it has actuators, and you can program the thing. These are actually pretty sophisticated robots. These are robots that would have been state-of-the-art maybe 15 years ago, right? There's another type of kit called beam robot kits. I don't know what beam stands for. I can never remember. But they often end up looking like insects, these little robot kits. They're pretty simple. A few sensors, a few actuators. But you end up with a fairly sophisticated little robot. And these aren't super expensive. So you can build robots yourself. You can join a robotics club. There's a club called FIRST. There's clubs all across the country in this FIRST organization. And it's a team. It's a team-based robot competition. So your team designs and builds a robot to compete against other robots that are built by other teams. You guys are in FIRST? Yeah. So FIRST is awesome. And what you find out is that robotics is not about sitting in your room working by yourself. It's about working with other people. And it's about coming up with great ideas in a collaborative way. And it's just a fantastic experience. And it's a great way to learn about the field and also have a lot of fun, right? You can learn to program computers, which I think all of you probably do at this point much, much better than I do, and much better than my father did. And then finally, you end up studying some type of science, engineering or computer science, physics or math. You can study history and become a roboticist. No one's going to tell you you can't. But it might be a little easier if you have some technical background. So last thing I want to get across, why is robotics important? Well, there are some very real reasons why robotics is important in today's society. Robotics can really improve a person's life. Here's an example of a person who's either been injured or had an illness and is undergoing rehabilitation. And in this case, you know, this is a kind of a manipulator-like robot, like you saw welding car parts. But in this case, the person is actually interacting with a robot, and it's guiding their motion during their rehabilitation to improve the outcome of their rehabilitation, maybe lessen the time that they have to do this physical therapy, or help them return to health faster or more effectively. So this is a robot that's actually directly improving someone's life. This is a robot that vacuums your floors. It's maybe not as important as rehabilitation, but it's kind of useful. You can sit on the couch and watch TV, and this robot does all the work. So this is great. I mean, this is a small but non-trivial improvement of your life, right? Last example. This is a robot that's going to go inspect a suspicious object, which might be a bomb or some type of explosive. And it's going to detonate that explosive at a safe distance from humans. It's a great use for robotics. The operator is standing, you know, a mile away, looking through a video screen to control this robot. 15 years ago, what would have happened would have been a guy would have put on a heavy suit, like a suit of armor almost, gone up to the bomb, and tried to defuse it himself or herself. And obviously, it's a dangerous situation. So if we can take people out of dangerous situations and replace them with robots, it's a big improvement. So last example. Robots allow us to go places that humans physically can't go. So I'm sure all of you know we've had 2 robots on the surface of Mars for the last several years, Spirit and Opportunity, the Mars exploration rovers. And at this point, they've traveled, I think, almost 5 miles on the surface of Mars. We can't safely send a man to the surface of Mars. So instead, we sent robots in their places. They've discovered a lot of interesting science that leads us to learn about the origins of life on Mars and possibly the origins of life on Earth. So this is something that just physically would not be possible without robotics. This is a cool video produced by NASA Jet Propulsion Laboratory. Shows this mobile robot, kind of like the robots you saw earlier, with the manipulator now mounted on the robot,